students, welcome to our channel MST Physics, where physics gets charged. In the last video we discussed electric field intensity to multiple charges. So now in this video we'll take electric field intensity to 4 charge system, but here these all are non-identical, means their magnitudes are not same and sign also not same. So in this case how we discuss, now I'm taking the problem that plus 16q, minus 16q, 9q and 9q plus and minus are placed at 4 corners of square, and our intention is to find the electric field intensity at a center. So for this, when I am coming to the letter, for convenience it is supposed to be first particle, second particle, third and fourth particle system. So in this when I am taking the center according to vector diagram, so this is due to first particle at the center, as it is a positively charged one, away from it. Due to second, it is a negatively charged particle, is a towards it, and due to third charged particle is a negative, so that towards it only. And as the fourth one is a positive, so that again away from it, so in the direction of E2. So this is the way you will get the directions of E1, E2, E3 and E4. And to write these magnitudes here, E1 is a 1 by 4 pi epsilon. Let the distance from all the charges is supposed to be x. Of course, this x is r by root 2. At last we are substituting this one. Okay, but I am supposing x, so that you can write a 16q by x square. And E2 is also be same. And E3 and E4 are same. And there are 1 by 4 pi epsilon 9q by x square. But here, to get the resultant of these two, E1 plus E3, they are not equal, so that we should add them. And next we need to add E2 and E4, and then by taking the angle between the two, then the resultant of the two will get final result at O is a lengthier one, isn't it? To simplify this in a very short time, so my point is again taking the square here with the center O and side R. So now my point is, instead of taking 4 charges, I am reducing this 4 charge system to the 2 charge system only, 2 particle system. So in this, if you are observing this vector diagram, E1 and E3 are away from it only, and both are in same direction. So 16 plus 9, I am writing here 25q. When I am writing plus 25q here, so definitely the resultant is away from this, along this only. Let it is E1. And again about these 2 charges, the resultant is downward, so that I am writing here again 25q to this side only, so I will get E2 this side. See, taking the 4 magnitudes, instead of that I am coming to the 2 only with the 2 charges. And one more thing, here I am adding the charges of either first, third or second, fourth according to their vector directions of individual charged particles, but not I am adding the magnitudes of these charges. This, sir, 16 minus 9, 7 sir. But how we are taking a 25q this, sir? I am taking this 25q of these two according to the vector direction of individual. Due to both the charges, it is towards this only. So when you are taking the sum, 16 plus 9, you will get 25q. So that I am written 25q. And sir, why you are not taking minus 25q? If you are taking minus 25q here, the towards downwards resultant. But according to this vector diagram, is the resultant is downwards? No. If you want to write minus 25, you can also again redraw the circuit diagram like this by keeping minus 25q here and one more minus 25q here. So that again see that this is the first one towards the negative, it is the second one towards the negative, so that again you will get same only. Understood? So now it is a very simpler to find. Why? Because E1 and E2 are equal. Why? Because these separations are same or not? So this is equals to 1 by 4 pi epsilon 25q, where the separation is x, that x is half the diagonal, is r by root 2 whole square. So that we will get the magnitude as 1 by 4 pi epsilon 50 into q by r square. Okay, and E1 is equals to E2. As these two diagonals, then definitely the result angle is 90 degrees here. When angle is a 90 degrees, so we can write the E resultant of first and second is a root 2 times of E1. That is a root 2 times of E1. So we can write the final magnitude as 1 by 4 pi epsilon 50 root 2 into q by r square is the resultant. See, after simplifying this circuit diagram, within a 2 steps I am simplified it. But whereas in my basic method is that at first I am taking the electric field strength due to individual charges 1, 2, 3, 4 and this resultant of the 2 and the resultant of the 2, again the resultant of 1, 3 and 2, 4 is a multi-step problem. Of course you will get the answer, but the time taking is more. But when I am coming to this model, so within a 2 steps I got the resultant. Here also you will get the same. That's the importance of this model here. Understood? And again now the resultant is definitely along this is the angle bisector now because of E1 is equals to E2. To understand this I am taking one more example. So here this is a square. At this square I am taking plus 8 cube. Okay, minus 8 cube and I am taking plus 2 cube and here it is a minus 2 cube, say for example. And again our intention is to find the resultant electric field intensity at a center. So in my basic method I need to write the direction of this first one, E1 is away from this and due to this E2 towards this and due to this away from this because of positive and due to this is a negative towards this. And after that on simplifying 1, 3, 2, 4 and after 1, 3, 2, 4 you will get resultant is the lengthier one. Instead of this, now according to my shortcut, here can I give, so here E3, E1, of the E3, E1 which is the greater one? E1 is the greater one. And then opposite means difference means 8 minus 2 is what? 6. And that resultant E1 is upward. You know, taking the resultant E1 upwards, okay, we need to take the positive charge where? Here. Understood? And again, here E2 is downwards, E4 is upwards. So due to negative charge. So resultant in what direction? Resultant is in what direction? Towards this. Why? Because it is a greater one. You should not be taking minus 8 minus 2. You should consider 8 and 2 only. According to the direction, it is the difference 8 minus 2. In order to getting towards this, what charge we should take here? Positive or negative? Negative. E2 minus E4. Resultant is in the direction of E2 because of 6 cube. So that to get towards this, here we should place minus 6 cube. Is the correct one. R. So the same thing, the same diagram. Now you can write what? It is a plus 6 cube that side. So means here you can write minus 6 cube. Or you may write this is plus 6 cube. Here also according to this diagram or this diagram you will get same. Is the realignment of these charges I am taking according to the vector direction of the electric field strength due to individual charges, please. Got my point? Not adding the charges or subtracting the charges here. That addition or subtraction will depends on the direction of field strength due to individual charges. So that instead of doing this many number of steps, here also according to this how many number of steps we need to do to write these two magnitudes and the resultant of 2 pairs. And after that angle between them and on simplifying you will get lost the answer of course. But here you will get within a one step say here plus 6 cube. So away from this is the A1 minus 6 cube towards it. On simplifying you will get the resultant within a 2 steps. You got the problem, please. Understood? So this is a way we can solve the electric field strength due to multiple charges when they are unequal. Thank you for watching. If you are like it, do like, share, comment and subscribe my channel to get more videos.